so let's try and fill in this table of values. I'm actually going to start down here because I think 0 and the positives are easier. So we'll procrastinate and do the negative exponents at the end. 2 to the 0 is 1. Anything to the 0 is 1. Okay, that is our definition. Okay, 2 to the first, well, that's just 2. When the exponent is 2, I'm looking at 2 squared. That's 2 factors of 2 multiplied together. 2 squared is 4. Okay. Now, with my negative exponents, 2 to the negative 1, remember that's just the reciprocal of 2. The negative exponent tells me that the 2's are going to be in the denominator, but my result is still positive. And if I look at 2 to the negative 2, that's the reciprocal of 2 squared. Okay. So that's going to be 1/4. Again, the negative exponent does not make the result negative. All right, so I can plot these points. So let's see. I'm going to, again, plot these points first. At 0, we're at 1. So the y-intercept is 0, 1. We've got the point 1, 2. And then we've got the point 2, 4. Now, if I think about what's going to happen as I plug in bigger and bigger positive numbers, 2 cubed would give me 8. 2 to the 4th would give me 16. Looks like my y values are going to be getting bigger and bigger and bigger. And it looks like as they do that, the graph is getting steeper. Okay. Notice in going from here to here, we went over 1 and up 1. Going from here to here, we went over 1 and up 2. Okay. Next one at 3, we're going to be up at 8. So the graph goes up and gets steeper. I feel good about that pattern continuing. Let's look at the left side of the graph. At negative 1, we're going to be at 1/2. So there's my point negative 1, 1/2. At negative 2, we'll be down here at 1/4. So it looks like as we go to the left, so that's drawing things backwards, my function is going down. Now, if I'm not careful, I'm going to just connect the dots and say, oh yeah, we're going down. That's wrong. Okay. Got to think about this pattern. It will be the case that I'm getting smaller numbers the further I go to the left. But am I ever going to actually hit 0? No. Because if I have 2 to the negative 100, that's 1 over 2 to the 100. Got a 1 on top. That's not going to equal 0. And that's a positive number on the bottom. So I'm never going to cross the x-axis and have a negative number. These y values that I'm getting will always be positive. There's no way I can take a power of 2 and get 0 or something negative. So, although going to the left, we're getting smaller and smaller and smaller, we're just getting closer and closer to 0. That x-axis is a horizontal asymptote. And you'll notice now with this exponential function, I was saying as we drew it backwards, our y values were getting smaller. Remembering that we read graphs left to right, this is always increasing. It's always going up. So that's my graph for 2 to the x, okay? And I can state its domain is all real numbers, okay? You'll notice I didn't bother to plot any points that had really complicated exponents. But I can sort of see, okay, 1/2, which I know would correspond to a square root, is between 0 and 1. So 2 to the 1/2 and the square root of 2, I know that's between 1 and 2. So all of the messy numbers that are in between those integers, they just sort of get filled in as I'm playing connect the dots. Okay. The range of this, oh, and I'm sorry, we've usually been stating things in interval notation, so let's make the domain negative infinity to infinity. It is the set of all real numbers, but we've usually been working in interval notation. Okay, the range is just my positive numbers. So that's going to be from 0 to infinity, not including 0. And this function is always increasing, has a horizontal asymptote on the negative side of the x-axis. Okay, now that's very different from the parabola we get with x squared. So if you remember the formulas, x squared and 2 to the x looked very, very similar, very, very different graphs. Exponential functions are very different from the polynomials and power functions that we've studied previously. Okay, what I'd like you to do before the next video is let's just try another one. Let's change the base. So this time I want to look at f of x being 3 to the x. Now we'll eventually be able to move past creating a table of values, but while this is still relatively new, for each new function we're going to go ahead and create a table of values. So I'm going to keep the same x values, plug in a couple of negatives, 0, a couple of positives, see if you can complete this table and sketch 3 to the x for me.